All right, we're doing the grammar of circles. Remember, grammar means not like English grammar, but this is like all the vocabulary that go with solids, okay? All right, here's the first bit of vocabulary. You have it on your note sheet, polyhedron. A polyhedron is a solid that is bounded by polygons. You just need to fill in the blank for yours. I think it's just polygons is what you need to do. It's a solid. It's not just flat on the table. It's now three-dimensional. It's a solid bounded by polygons. Remember, polygons can't have curved edges. They have to be enclosed and so forth. Okay? Next, we have faces. On that shape, that polyhedron, it has faces. And these faces are the polygons themselves. So this is the polygons in the polyhedron. You've got a picture that will come up soon. You can see it next door. You can see the faces. Now we talk about the edges. The edges are the line segment formed by the intersection of two faces. So it's where the faces come together are your edges. It's going to be really important that you actually have your shapes in front of you so that you can feel them. You also have a vertex or some vertices. And the vertices are the points where three or more edges meet. I'm going to actually get in front of you guys. You can come see me. I'm going to show you with the polyhedron here. I'm going to get up here the dodecahedron. I'm going to get the dodecahedron. We have all these faces out here. We have the edges, and that's where the two of them come together. And then we have the points, and those are the vertices, okay, or of a vertex, okay? This is a cone, and it is not a polyhedron because it's got a circle as a base. If it's got a circle as a base, it is not a polygon, so it's not a polyhedra. Which other two are not polyhedrons? Go ahead, anybody. Cylinder, and you don't have it right here, but you will do a sphere. It's not a polyhedron, okay? We have this one is a pyramid, and they all come up to a vertex at the top, all right? Are there any questions about these vocabulary words? Okay. I've got the picture up there that's the same one on yours. You have the faces and the vertices and so forth, and the edges. You're going to need to know those vocabulary words because if they ask you for them, you'll need to know what's going on. All right, let's just look up here. I want you to, this is not on your note sheets right now, but it's really important that you know the difference between a prism, a pyramid, a cylinder, a cone, and a sphere. You need to know those. So let's do some comparisons. How can we compare a prism and a pyramid? What does a prism have, or what does a pyramid have that the other one doesn't?
Well, the prism or the pyramid has like one point at the top.
Yes, that pyramid right there has one point that it all comes up to. What else can you say about the prisms and the pyramids here on this little area?
Pyramids have triangles, prisms don't.
Okay, so pyramids have triangles here. And prisms, what shapes do they have? Rectangles, that's correct. Or squares, but squares are rectangles, so that works. Okay, so prisms have quadrilateral, rectangles, where pyramids have triangles. Okay, all right, let's move on to, all right, compare now a cone and a pyramid, the two down here. A cone and a pyramid, how are they the same, how are they different?
Triangular like point.
They both have a point, right? They both have a point at the top.
One has a circle on the bottom, one has a square.
This one in particular, that one has a circle. This particular one has a
one's rounded, one's
rectangle bottom, but pyramids can have different shapes as their base, yes. Mm-hmm. But cones specifically have circles, right?
They're rounded.
They're rounded.
Snow cone.
That's like a snow cone. That's like the cone, like an ice cream cone, cone upside down. Yes. All right. Let's compare a prism and a cylinder. How are they the same? How are they different?
One is rounded, one has sides.
Okay, one is rounded. The cylinder's rounded.
They both have two bases.
They both have two bases. This one has, here's a base here and here. And then the prism also has two bases, okay? They both have two bases. As opposed to these down here, they both had one base, right? Okay? These also have like a faces that go around, and as opposed to this also has something that goes around the bases. Okay, let's compare the sphere to everything else.
It's completely round. It has no points
No
at all.
sides.
Yeah, no points
No
at all, no
bases,
sides
no
at all, no
sides.
bases at all. It is like totally unique compared to all these of them. All the rest of these here have, including these, have some kind of base. The sphere does not.
Yeah.
Okay.
But it's kind of like the cylinder and the cone in the sense that it's somewhat circular.
Yes, that's true. That's true. These all have some kind of circle to do with each other. Yes, that's true. I just brought this up, and all these here are called the polyhedra. These ones are not. Okay. Questions about this slide? On your homework, you're going to be naming these. So you need to know the difference between a pyramid and a prism, a cylinder and a cone, and so forth. Okay? All right. Now we're going to find some relationships. There is a pattern. So you need to have your shapes out. You need to have a tetrahedron out. You need to have a cube. You need to have an octahedron, a dodecahedron, and your isosahedron in front of you. Don't worry about your pyramids and your cones and cylinders right now. I want to point something out to you. Your isosahedron, I spelled it wrong on your Mad Minute video. It's not a problem, but it's got an I-C-O-S, not I-S-O-S. Just so for your information, okay? All right. You need to have those in front of you. You should have them in front of you. We already got that for you. We're going to find the relationships between their faces, their vertices, and their edges. You need to have your note sheet down below down here. We're going to do them in order. So if you want to start writing their words, tetrahedron down there. We're going to do cube next, octahedron, dodecahedron, and isosahedron down there. We'll do 3 more after that. But if you want to start writing those, I'm going to get into a spreadsheet so we can write these things down. Mine will look similar to yours. All right, I want you to get your tetrahedron out, and I want you to count the number of faces that it has. And then tell me what you got. Let's do Amy first. Then how many faces does a tetrahedron have?
4.
Okay, 4. Let's move over to vertices. Vertices, that's the points. How many points does your tetrahedron have, or vertices?
5. Or wait. 1, 4.
4, she says. 4. And what about edges? These are the ones that are hardest for me to keep track of all the edges.
6.
I heard 6. Okay? And so our job right now is, if we had some really weird shape that had lots and lots of faces and edges and vertices, and if we didn't want to count all of them, we wanted to have some kind of formula to figure it out. I want to see if we can figure out a pattern with them. All right, Brett, do you have your shapes in front of you?
Yes, ma'am, I have some of them.
Good. Do you have your cube made?
I do.
Can you tell me how many faces the cube has?
6.
I got 6 when I counted. What about vertices, Naraya? How many vertices does it have?
I'm getting 8.
Does anybody else get 8? I got 8. Is that what you got, Heidi?
That's what I got.
Yeah, okay, now the edges. Again, those are the ones that's hard for me to see. You have to count all of them, then I kind of get myself confused on...
12.
I heard 12.
4.
12, yeah.
12, okay, 12. Okay,
It'd easy for me if I counted in 4s.
Yeah, me too. All right, now, we're going to stop here, and we're going to make some predictions. These numbers 4, 4, 6, and 6, 8, 12, is there something we can add, subtract, do something to get the other ones? Can we do something with them to get the other ones? So you said that, one more time, we take what times this, the faces times 2?
Yeah, to get
So that times 2 will give you that one. Well, if that's true, then it should work for up here. 4 times 2 is 8, which is not that one. Okay, so let's try another option.
I don't know about the faces, but well, never mind.
What other options do we have? Can we do something with the vertices and the edges, or the vertices and the faces, or?
On tetrahedron, if you multiply by 2, you get the cubes, but I don't think that's gonna.
Oh, I was just thinking going across.
Yeah, that's what I was trying to
Yeah,
figure
just going
out.
across with a 4, 4, and 6, and 6, 8, and 12. Let's move on to the octahedron, and maybe we'll be able to do it. Let's do octahedron. How many faces does your octahedron have?
8.
8, I heard. I agree, because that's why they call it an octahedron, right? Okay, so then how many vertices? This is
6.
4 around and 2 on the top. Yeah, I agree, it's 6. The edges is going to be hard now. Okay, I got 12 when I did it.
I did too.
Okay, so let's see if we can make a prediction now. I mean, make some kind of relationship. We got 8, 6, 12 now. How does it work? Can we add something, subtract something, put something with it? Is there always one that's bigger than the others?
Add the two vertices, add the faces and the vertices together and minus 2.
Add the faces and vertices together and minus 2.
To get the edges.
So let's see. This is what her prediction is. Let's see if this works. So she added these two together and gets what?
8.
8, right? We add it together and it equals 8. And then what do we do to get that then?
Minus 2.
Minus
that
2.
one.
Does that work always? Add these together and it's what?
14.
14. And if I subtract 2, I get that, right?
And it's the same because it's 6 and 8 and 8 and 6. So those two are the same. Cube and octahedrons are just backwards.
Oh, right. Cubes and octahedrons are just backwards. Let's see if this works on the rest of them. So you think we have faces plus vertices minus 2. So right now,
Now the problem is we have to figure out vertices, which is hard to count.
I think the edges is the hard ones to count.
I got 12.
So if we do the
That's not
dodecahedron,
Alright.
well, how many sides does the dodecahedron have?
12.
12? That's why it's called a dodecahedron, right?
Wait.
But the vertices, I don't think is as hard.
Dodecahedron, not isosceles.
Oh, yeah.
The dodecahedron.
6. No, I got, wait. You have 1, 2, 3, 4, 5.
You got 20?
10.
Vertices, yeah.
20.
12. 13,
So then let's just
You
make
got
sure.
5 on the top, 5 on each base,
12.
and then 10 around.
Is it going to be easier to write the vertices than the edges?
No,
Are you
we
guys
should
doing
write-
the
Vertices. Oh, I've already done the points. Or
Yeah, that's
the
what we're
vertices.
talking about.
Oh, yeah, I got 20 points. I was
20
about edges.
20 vertices?
Okay. Yeah, vertices.
So then if her prediction's correct, then this should be 32 minus 2 should be 30 here, right? If Naraya's prediction's right, we should have 30 there. And is that true? For the edges.
Can we look at some that are not put together, like that are just down and count them that way?
Oh, so you think it would be easier if they were flat and add before we
I
folded
don't
them?
I don't lose track. I can put a dot on them.
Yeah, you can put a dot on them.
Wait, what did you say about?
30.
30.
30. All right. 30.
So I was right?
So far, so right. That's correct.
It's
Good
what
job.
they say.
I agree with that.
That's what I got.
Oh, my bad. Wrong one. I agree with that. What about vertices?
I mean, unless I was missing something,
These are
20.
20?
20?
20 vertices?
No.
Edges.
Faces.
Oh, I got
Faces.
it.
Right. What about vertices?
Can I go around this with the points?
Oh, 12.
Yeah, so I
Okay,
was
so 12 vertices.
right. I was
Okay.
right, which is weird.
12. Now,
42.
edges. So you...
20.
I think it's 30 again. They're just...
Yeah, that would be right.
They're just
30,
flipped.
that'd be great.
Isosahedron and dodecahedron are just flipped from each other, right?
Yeah, it's just flipped.
By the way, Naraya is correct, so although they wrote their little formula a little different than Naraya writes it. But, so let's go to the
How
regular...
did they write the formula?
You're going to be pleasantly surprised in just a moment. I'll show you. Where am I at? I am right. All right, so we're going to come up here. Now we have a rectangular prism. I'm going to tell you right now, your rectangular prism, you have one, but it's also a cube. is a rectangular prism. It's got 6 faces. 6 faces. I'm going to tell you it's got 8 vertices. Based on that thing, that the prediction that we've made with the faces plus the vertices minus 2 equals
12.
The edges.
the edges.
Oh. Wait.
All right?
Plus V
Does that look familiar to you?
wrote down.
Does that look from? Does what I just wrote up there look
That's what I
familiar to
wrote
you?
here.
Yes.
Kind of.
No, it doesn't.
Kind of.
What does that look like to you?
Euler's
Euler's theorem, except what is it? How is it different?
E is on the opposite side of the equals.
No.
Like, or you subtracted the 2.
Add the 2.
Yeah. So
Oh,
if I just move the
subtract
2 over to the other
Add.
side,
Well, if you
it will
take
be a
this
plus
here-
2, right?
Oh, you're doing it that way.
So
too,
if
Euler.
we did this,
I'm
f
Euler's
plus
theorem for that.
v equals e plus
Wow.
2,
Yeah, I'm
it'll be
doing
the same
it.
thing, right? And Euler's theorem, we wrote it like this: e plus 2 equals f plus v, right? So we figured it out. That's our Euler's theorem. It's going to work. So we can just automatically just go to the rest, right? We can just do the edges as 12 because we just add those 2 together and subtract 2. Because I think that personally the edges are the hardest ones to count. I don't know about you guys. Did you guys think that the vertices were harder than the edges?
No.
Okay. Now,
I think they're both hard.
I want you to notice this name.
The
This
edges
is
are
called a
pretty okay.
pentagonal prism. Why would it be? And then you don't have a shape like this in front of you. And I have it up here on the bottom. Why is this one called a pentagonal prism?
It's got a pentagon on it.
Because the base is a pentagon, okay? This was a rectangular prism because the base was a rectangle. All right, this is very important. You're going to have homework where you're going to have to name these. We're going to talk about them. Notice it's got the word pentagon with an A-L at the end. Pentagonal, prism.
7.
How many
7.
faces does it have?
7.
7, because we have, my bad, I just did something I wasn't supposed to. It's got the 1 and 1 there, that's 2, plus the 5 that are around there, right? So total of 7.
They have 10
And then the vertices is going to have the
Yeah,
5
10.
that are here, 5 there and 5 there, and that's done, 10. So then how are you going to figure out the
15.
edges?
You do 7 plus 10 minus 2 equals 15.
15, all right. All right. Hexagonal, and this is a way to name it. It's got hexagon for the base, and it is a prism, a prism. How many faces is it going to have?
6. 8.
Yes, I agree with that.
8 faces, 6 vertices.
8 faces.
Yes.
How many
Yes.
vertices?
Oh, wait. No, it would
12.
have 12.
Yes, because we got
12
this.
vertices.
You got a double.
8
yeah.
was front and back, and then all the 6 that are around there.
18.
Our vertices are going to be 6 here, and then that many back there. So a total of 12 vertices. So then how do we figure out the edges?
8 plus 12 minus 2 equals 18.
All right. All right. Fantastic.
Just keep it this simple.
I think this was really cool. Let's go to pyramids now.
cool.
We got a square pyramid. Notice I'm naming it. It's a square pyramid. Why is it going to be called a square pyramid?
Square on the base.
Because it's got a square on the base. We can have lots of different shaped pyramids. Thank you for letting me know. I've got 5 faces. Are you with me so far? 5 faces because we have 4 triangles all the way around and 1 at the base. 5 vertices, 4 at the base, 4 at the base, and 1 at the top. So how many edges is it going to have? 8. Add them together and
Wait.
subtract 2. Yes.
Oh, yeah.
All right.
We're not writing
Fantastic.
this down, are we?
Pentagonal pyramid. You do not have a pentagonal pyramid. You have, what kind is yours?
Hexagon.
A hexagonal pyramid. But this is a pentagonal pyramid. It's going to have how many?
5.
It's going to have base
9
faces
and
is going to be
5.
1 on the bottom, and how many going around? You're going to have, those are going to be 5 of those triangles around there, right?
Oh, it looked like 4. Okay. Oh, I see the line. Yeah, so it would be 6.
And then this base, it's hard for me to draw this 3-dimensional.
Yeah.
Underneath there, that's 1, the base, right? So it's going to have 6 faces. And how many vertices? Pyramids are a little easier for me to do vertices.
Would be
6.
Yes, because we have one for each of, yes, 6 vertices.
I like having those little, those big
Those-
dots.
Yeah.
Yeah, that helps, doesn't it? 6 of those. So then what does that mean for its edges? 10, I heard?
Wait, because 6. Oh, wait.
Yeah, 10.
Because it's these.
yeah.
Add those together, that's 12.
12.
Subtract 2 makes 10.
Yeah.
All right.
I did math in my head.
Very good. Very good. And you guys can write. Now this is really cool. Based on what we found, this is a buckyball. What does it look like to you, Heidi?
Oh, wait. Are those one of those balls that, like, they go in and they, like...
Oh, this is just a buckyball. It's the same as a soccer ball.
Ow.
All right.
Okay,
And I don't know why it was called a buckyball. When I found it, it had that. I'm going to just tell you right now that it has 32, 12 pentagons and 20 hexagons, and it has 60 vertices. So I'm not going to ask you to count its edges because that could be crazy.
9.
I heard how many?
90.
90. How did you get that?
I did 32 plus 60 minus 2.
Fantastic.
Or just 30 plus 60.
Add those two together.
30.
32 plus 60 makes 92.
Or you just do 30 plus 60.
Yes,
You
you
let
can.
the twos
You can
cancel.
subtract
Yeah,
the twos
just
any way you
subtract,
wanted.
yeah.
Yeah, you could have. You can, and we subtracted the 2 makes 90. All right. Yeah. All right. I got 90. We did this whole activity so you could get Euler's theorem, basically. Now we're going to go to Euler's theorem in just a moment, though. All right. The way you name a solid is first you name its base. You name its base. Its shape of its base. Now, if it's a circle base, though, it's going to be either a cone or a cylinder. And if it has no base at all, it'll be a sphere. Other than that, you go with its base. After that, you decide if it's a pyramid or a prism. Here are some examples of the ones you will have on your homework.
Oh my
You could
goodness.
have
Wait a minute. Can I,
a
like...
triangular prism. You could have a square prism, a rectangular prism, trapezoidal prism, a pentagonal prism, and a hexagonal prism. Those are the type of prisms you could have. You could have a triangular pyramid, a square pyramid, a rectangular pyramid, pentagonal, and hexagonal. The ones that are totally not prism or pyramid would be your cylinders, cones, and spheres. We're going to do some examples of this. We're going to do numbers 1 through 4 together. The shape is a prism for its base. This is number 1. It's pentagonal.
Number 2, would we call that square or rectangle?
Just a second. Pentagonal, is this a prism or a pyramid?
Rectangular... Oh, wait.
This is a prism or a pyramid?
Oh, prism.
Prism. All right, I got
Maybe
people running ahead me. All right, let's go to number 2. Are there any questions about number 1?
That would be...
Number 2, what shape is that? Is that a rectangle or a square? Be careful. It might not look like what it is, but you need to go by the, is that rectangle or square?
Oh, that's a rectangular... Oh, wait.
It's technically a square.
It's a square.
It's technically a square, but squares are rectangles, but you need to be specific. Because of these little lines right here, it is a square.
Okay.
So how would we write that? A square pyramid?
Just a square pyramid,
Okay.
yes. Did I spell pyramid right?
Pyramid, though.
Thank you.
Yeah.
Pyramid. Thank you.
This could be a cylinder.
All right, so that didn't look right to me. Square pyramid. So we first start with the base, and then we tell if it's a pyramid or a prism, cone,
Would the base be...
cylinder, and so forth.
Yeah.
All right, let's move on to number 3.
Yeah.
Number 3, what shape is the base? Heidi, what'd you get for the shape of the base?
Yeah, hexagon.
Yes. So this is going to be hexagonal. And then is this a pyramid or a prism? What about you, Amy? Is it a prism or a pyramid?
It's a pyramid.
I agree. I am not spelling pyramid today.
Oh, what the...
Pyramid. Okay. All right. Let's move to the last one that we're going to do together. Number 4. All right, number 4, what kind of base does it have? All right, what kind of base does number 4 have?
It's a circular
A circular, so we don't even do the pyramid or cone. I mean, it should be pyramid or prism. We either do cone, cylinder, or sphere. Which is this one?
2 bases.
Which is this one?
Oh, never.
Cylinder.
Cylinder. Thank you.
2 bases.
Oh,
There's
okay.
3 of you.
Yeah, I see it.
Cylinder. Are there any questions about these kind of questions? So the ones that you have made that you're being quizzed on for your Mad Minutes are the Platonic Solids. They're called Platonic Solids because they're named after the famous mathematician Plato. And you have a tetrahedron which has 4 sides. We've gone over these before. Your cube is also a Platonic solid with 6 faces. Your octahedron is also a Platonic solid with 8 faces. Dodecahedron with 12 faces. And your isosahedron with 20 faces. Your Platonic solids, you have built them. Here's what they look like. You've seen them on your Mad Minutes, or Formula Madness, excuse me. And you have to identify them for your Formula Madness. All right, Euler's theorem, we just discovered it. There is a relationship between the faces, the vertices, and the edges. We discovered it together. You guys discovered it with this 2 being on the other side, and that's not a problem.
-2.
You just minus 2 from them. It really doesn't matter how you calculate it, okay? I would like us to, again, that's one of your Formula Madness. I would like us to go and do some examples with that. You're going to do some examples on yours, on numbers 16 and 17, if you'll move to 16 and 17. I'm going to go there now. You'll use, I actually want to do it at 15. I'm going back to 15. We will do Euler's theorem with 15. I want to show you. We're going to verify Euler's theorem for each of the Platonic solids. So I'm going to explain what I mean by verify the theorem, okay? So I wanted you to write F plus V equals E plus 2. And for A, for your tetrahedron, you have enough, your pencil can write right next to it. Your tetrahedron, I want you to write the numbers right underneath to verify the theorem. How many faces does a tetrahedron have?
4. Sure. Yeah.
4 plus V, if their faces, excuse me, vertices?
4.
4. And then your edges?
8.
Mm-mm.
Edges?
Uh-huh.
8.
6.
6.
Plus 2. Does that verify?
Yes.
Is 6
Oh,
plus 4,
oh,
does it
okay.
equal 6 plus 2? Is this a true statement?
Yes.
Then you can check that it is. Check mark. You have verified it. You will do that with a cube, an octahedron, a dodecahedron, and an isosahedron. All right?
Okay.
Okay. Now we're going to do number 16. If you'll move on down.
Question.
Yes, ma'am. Go ahead.
What if we do, or what do we do if we get to one of these and it's wrong?
Then you have, if it doesn't check, then you've counted wrong on your edges and vertices and so forth. Okay? All right. Number 16, Nariah a little while ago asked if we could have them all cut out and flat. And that's what we're going to do. This is a very good thing for you to do and to be able to determine this, okay? So what they want you to do is the instructions say, copy the measurements given onto the net of each. This bottom thing is called the net, or what is after it's all flattened out. So where would the 9 go on this solid?
A radius.
It's a radius of one of them. It doesn't really matter which one you choose. You're going to copy it down there.
Great.
Where does the 17 go? Yes, ma'am. Sir. Yes, sir.
My internet's gotta do better.
Where does the 17 go?
On the short side of the rectangle.
On the short side of this rectangle. You could put it there, or you can put it over here. And that 9 could have gone in here also. So you need to realize that the answer key might have it a little different. Actually, I'm going to show you what the answer key does have. The answer key has, it looks like that. So depending on how you put yours on, this is what the answer key looks like. Okay? Yours might be a little different. All right, let's do, I'm going to let you do 17 by yourself.
We do 18 together.
Oh, I suppose we'll do 18 together. Okay. What is 4.8? What is 4.8 called? What is this called?
The altitude?
No.
Right, no.
Starts with an A though. The
Opossum.
The apothem. So that apothem is on one of the bases, and it's like right in there, or right in there.
Wrong way.
Is this what you got?
What do you mean?
You went towards the triangle, towards the angle.
Oh, I did. It's like one of these. It can go here.
I think this is that.
Yeah, it is not here, by the way. I apologize. Yes. It's like that.
4.8.
Oh,
That's your 4.8.
Yeah, that works.
well, it can go around any single side of these.
Which one's the 6 and which one's the 7?
Is that 6?
The 7 would be
It'd be
would
one
be
of
the
the
one
sides.
connecting to the pentagon, or it would be one of the sides in the center box.
It would be one of the sides that's adjacent to wherever you.
Is that a
drew.
6 or is that a 7?
That's a 7.
That's a 7. So all these are the 7s,
Although
right?
the 7,
Yeah.
it's saying.
The 7 has to be touching.
It has to be one of the edges
it has
of
to
the
be one of the edges
pentagon.
of the pentagon.
Yeah, it does. It has to
Yeah,
be.
it doesn't have to be one of the edges of the square or the rectangle.
That's right. So what?
Yeah,
where's
it
the
does.
right?
Yeah, it is.
Yeah,
7s have to be. So what's the 6 at?
One of the edges of the what am I thinking? The square.
Yes.
The individual rectangle
Rectangles.
squares.
Yes.
Rectangles.
Okay.
Okay.
Okay. Any of those? Any of these are 6.
Aye.
You only have to say once. Okay. This is really important for you to actually. This is for your mental ability to be able to spin things around and turn them and so forth. Okay. Now that we have finished doing some sample problems, let's review. In this lesson, you learned what a polyhedron is, and you know the vocabulary that goes with it. You know what Platonic solids are. You know what Euler's theorem is. We also talked about some net solids. We named the polyhedron. I hope this has all been helpful. Goodbye.